Okay, I have one of the shafts done, which is here, and it's now welded and ready to be turned again. So, as I said, the diameter of this shaft is 60 millimeters, but it actually is a few hundreds over, and I was able to get it turning so true. This side is not all the way cleaned up, and it was running like 200s at most off on the ends, but I guess the shaft is a little bit bent because it was cutting more in the middle. So now I'm doing the second one. So first I'm indicating the end to be turning through, and then I'm gonna face it and center drill it. And let me show you this. This is averaging about 47, and the other way it's also about 47, and this way it's maybe 45, and right here it's also 45. So it's not possible to get it running any truer than that. So now let's face and center drill. Okay, now walking between centers. So it's the other side with the center hole is on a live center, and I have dialed in this side. So here it's about +2, +2, 0, 0. That's as good as I can get it. And now for the other side, of course there's no adjustment here, but let's see. Let's see how accurate my center hole is. A little bit rough surface. Maybe +2 here. Same here. +3 here. And +3 here. So I would say it's very much near, very perfect. And for the sake of it, let's check this. So now when I move the carriage, this needle should move as little as possible. Okay, it jumped to 5 almost immediately. Let's go back. Now it's 5. Okay, there's a little bit of something going on in here, but other than that I would say it's very close to being 0. So we can now take an extremely light skimming pass on this shaft. But I'm gonna change tools because I still don't wanna wear out this new Sandvik insert. I'm gonna use a little bit more used insert. Okay, here we go. That stuff must really be wearing down the insert. Okay, I got a pretty good fit. Really nice. Again, you can see it didn't clean up all the way, but I'm gonna have to leave it like that. fit is really good, very close. I think it's maybe like 200s only. It wouldn't hurt to be even a little bit more loose, but this is how I'm gonna leave it. Very good. Okay, now I have centered this end on the chuck as well as I can, and the idea is now to make a 50mm relief in here, which is 59.35mm in diameter, so that it will have a 400 press fit to this hole right here, and then I will heat shrink it. I mean, this will be heated to enlarge, and then I will just slide the shaft in and let it cool, just like I did with the previous shaft. Okay, now let's machine this end. Facing the end. This is the final pass. (59.34), exactly what I was looking for. Again, it moved a little bit. One thing I don't like, by the chips that this material is making, I think this is some kind of very low alloy steel, and also very light strength. So I hope it's gonna hold. Again, I have no idea what kind of a material this is, but it cuts very freely and the chips like to break on their own. So I think this is not a very good quality stuff, or maybe it's some kind of a free machining steel. Okay, a little bit filing to the end and we're ready to go do the heat shrinking. And this is how I'm doing the heating. After a while I will move the torch to the other side. And when both sides have turned blue a little bit on here, I will measure the bore, and if it seems to be good, then I'll just do the fit. So I will show you how I do the fitting. Okay, let's see what kind of a diameter we got here. Trying not to scorch my caliper. 39. So we should have a little bit of room for error even. Shutting the torch, which by the way is almost out of gas. Okay, let's see. There we go. Okay. So here we have it. Now ready to weld. Okay, now I'm putting a few stick 7 or 18 beads around it. This is the second bead. It's not all the way around already. Yet, I mean. I think 1 or 2 more passes.